Hello everyone. Welcome to the logical reasoning and data interpretation section discussion of mock. So in this session, first we'll look at the sets that were given in mock 12, then analyze them, rate them as per the difficulty level, and then we'll discuss the overall difficulty level of the paper, and then we'll be solving all the sets. Okay. So coming to the first set of the section. So some company makes 5 common alloys, alloy A, B, C, D, and E, which can be mixed in any proportion to suit the needs of the customers to make different alloys. So the following chart gives the percentage breakup of metals present in each of the 5 alloys. So we have 4 different metals here: copper, tin, aluminum, lead, and we are given with the percentage distribution of these 4 metals in these 5 alloys. And we are also given with the prices per kg of each alloy A, B, C, D, and E. Okay. Now from this we can determine the percentage distribution of these 4 metals in each of these 5 alloys. Now if I look at the questions, if a customer needs an alloy containing at least 25% lead and at least 25% tin, okay. If not more than 2 kgs of sorry, my bad. Alloy A, B, and C, D, and E, 6 kgs of alloy containing copper, fine. So if, and what is the least cost? So these 4 are independent questions, isn't it? So we have to make different cases. So I will not be, and if all the remaining questions are difficult, since I have understood the data that was given to us, I might attempt solving this set only when the remaining questions are difficult and I do not understand any of them. Now, coming to the second set, study the given information and answer the following questions. A total of 60 teachers from a university participated in an annual function. Each teacher who participated teaches at least one subject out of physics and biology and has at least one hobby from among singing and dancing. So the following table provides the number of teachers among the 60 for any combination of the subject they teach and the hobby they have. So we are given with a small table, and in the table above, the value in the third column and third row, that is 37, represents the number of teachers who teach biology. And the value in the third column and fourth row, 24, represents the number of teachers who teach biology and have a hobby of singing. So here you can have teachers teaching physics and having hobby as singing or hobby as dancing. Same for biology, and you can also have some teachers who can teach both physics and biology and who can also sing and dance as well. So after reading till here, I can say that this set is a 4-set Venn diagram and we are given with definite values. And if I look at the questions, how many teachers teach both biology and physics and have dancing as well as have singing as well as dancing as a hobby? So how many teachers teach biology but not physics and have a hobby of singing but not dancing? So you will be having definite answers for all these questions. So all you need to do is you need to make a 4-set Venn diagram and you need to find the values corresponding to each region. So if I compare the previous question with this question, I consider this question easy. So I will be attempting this question first and then I will be moving to the previous question. Now the third set. On a particular day, 5 buses, bus 1, 2, 3, 4, and 5 are distant for the same bus terminus started from different starting points and travel for different times. 1 hour and 40 minutes, 2 hours, 5 minutes, and so on. And the journey of buses started at different times: 11, 11:25, 11:45, 11:50, and 12:50. Now it is also known that no 2 buses reach the bus terminus at the same time. So we are given with 5 conditions. Now you have to determine the starting time of each bus, the time of journey, and also the after finding these two, we can anyway determine the reaching time. So this is a question from puzzles, and also I can say that this is a question from numeric logic. Puzzles with numbers, isn't it? The only I consider myself strong at puzzles, but if I look at the number of statements that were given to us, there are only 5. No. So deep analysis is required to solve this question. So I will be attempting second question first, then I might attempt this and first question. But comparatively, I find set number 2 easy when compared with this set. So in this set, eight students from different colleges XYZ won medals in different race events, 100 meters, 200 meters, and 400 meters, but not necessarily in the same order. Now they are not more than 3 students from any college. Each student has won one medal, and there are 3 medals at maximum for each race event. Number of students from college Y and Z are same. H is from college Y, D and G are not from the same college. So this is also another question from puzzles, and we are given with more number of statements, and this is a 6 question set. Okay, so I will be attempting second set first, Venn diagrams, because all we need to do is we need to fill the numbers corresponding to all the regions in that Venn diagram. Now if I have to choose one question between this question and the previous question, I will be choosing this, because I can solve this question just by making a simple table very easily, and by using Dix and cross method, isn't it? So this is my analysis of this paper. So everyone should be in a position to score 12 marks at least in this set, in this paper, and this is definitely not an easy paper. It's on a relatively moderate side, and you can expect questions of a paper of this difficulty in your CAT. And trust me, please pray or please wish for a paper of this difficulty. Okay, so please don't pray for paper where you have easy questions, because everyone will be able to solve. Okay, now let's move ahead and let's solve questions or sets of these papers. I will be coming to this set at last. Venn diagram question. Question from Venn diagrams. Okay. So here, the only catch in this question is a total of 60 teachers from a university participated in an annual function. Each teacher who participated teaches at least one subject out of physics and biology and has at least one hobby from among singing and dancing. This statement is very important, guys. Okay, so because if I make this 4-set Venn diagram where this represents physics, biology, singing, and dancing, all the teachers teach at least one subject and has at least one hobby from among singing and dancing. So at least one subject and at least one hobby. Now, if you really understood this statement, then your job becomes easy. The reason being, so they should be teaching at least one subject and they will be having at least one hobby out of singing and dancing. So you cannot have any teacher who teach only physics, because they need to teach one subject and also they need to have a hobby, either singing or dancing. So you cannot have teachers who teach both physics and biology because they need to have a hobby. Now this will also be 0. Now you cannot have teachers who have only hobbies singing, because they should be teaching at least one subject among physics or biology. Same here, this part will be 0 and this part will be 0. So this is the key statement to answer this question. So if you have missed this, then I can say that you will be wasting a lot of time in considering variables and solving for them. Okay. So now you will be having 9 variables. Let this be A, B, C, then P, Q, R, and X, Y, Z. So if you do not interpret this statement correctly, you might be having 9 plus 6, 15 variables to solve. So if you do not consider this statement, I can tell for sure that you have wasted at least 10 minutes in solving this question. So you need to be very careful while reading statements of a logical reasoning question. Clear? Now, so 33 teachers teach physics. So I can say that A plus B plus P plus Q plus X plus Y is equal to 33. And now you have 37 teaching biology. So B plus C plus Q plus R plus Y plus Z. This is equal to 37. And we also have A plus B plus C plus P plus Q plus R plus X plus Y plus Z. Now this is equal to total 60 teachers. So from this, I can say that C plus R plus Z will be equal to 60 minus 33. So C plus R plus Z will be 60 minus 33, which is 27, and A plus P plus X will be equal to 60, 60 minus 37, 23, and B plus Q plus Y. B plus Q plus Y is equal to 10. Now I have three equations in terms of C, R, and Z, A, P, and X, D, Q, and Y. So you have 23 teachers who teach only physics, 27 teachers who teach only biology, and 10 teachers who teach both physics and biology. Clear? So we have three equations. So let me write these equations side by side so that it will be easy to solve for us. So you have C plus R plus Z is equal to 27. A plus P plus X is equal to 33, and B plus Q plus Y is equal to 10. Perfect. Now, so physics and biology. So you have 10 persons teaching both physics and biology. So 37 biology. Now coming to 25 physics and singing. So the region common between physics and singing. So nothing but A plus B plus P plus Q. A plus B plus P plus Q. Now this is equal to 25. Now let this be equation 1, let this be equation 2, let this be equation 3. Now 2 plus 3 minus this. So A plus B, if I add these two, now we will be having A plus B plus P plus Q, which is equal to 25. So X plus Y will be equal to 43, 43 minus 25, 18. So the sum of these two is equal to 18. Now we have one more equation in terms of X plus X and Y. Now we have considered this. Now teachers who teach biology and uh, whose hobby is singing. So B plus C plus Q plus R is equal to 24. Now we have a total, you have 41% singing. So A plus B plus C plus P plus Q plus R. This is equal to 41. Similarly, you have 38 persons dancing. So 38 teachers whose hobby is dancing. So P plus Q plus R plus X plus Y plus Z. This is equal to 38. Now we are given that 19 teachers have hobby as both singing and dancing. So P plus Q plus R is equal to 19. In that case, A plus B plus C will be equal to 41 minus 19, which is 22. And X plus Y plus Z will be equal to 19 because sum is 38. So we have three more equations. Perfect. Now B plus C plus Q plus R is equal to 24. Now where can we substitute that? B plus C plus Q plus R is equal to 24. So from that we can say that A plus B will be equal to 41. 41 minus 24, 70. So we have used this. Now coming to the number of teachers who teach physics and have a hobby dancing. So P plus Q plus X plus Y. This is given to be 20. Now we know that X plus Y is equal to 18. So P plus Q is equal to 2. One minute. So how did we get X plus Y? A plus P plus 33 plus 10, 43. And A plus B plus P plus Q is equal to, sorry, A plus P plus X. This is not 33, my bad. This should be 60 minus 37, so 23. So if that is 23, then X plus Y is equal to 8. So if X plus Y is equal to 8, P plus Q should be equal to 12. Okay. Now we have X plus Y plus Z is equal to 9. Okay. So if X plus Y plus Z is equal to 19, if X plus Y is equal to 8, Z should be equal to 11. Now where do we have Z? As of now, no. Okay. Fine. Now the number of teachers who teach biology and have a hobby dancing. So this is nothing but Q plus R plus Y plus Z, 11, and this is equal to 25. So Q plus R plus Y is equal to 14. Now do we have Q plus Y somewhere? No. So we have also considered this. Now Z is equal to 19. How can we find the value of Y? P plus Q is equal to 12. Now P plus Q plus R. P plus Q plus R is equal to 19. So the value of R should be 7. Now C plus R plus Z. Where is C plus R plus Z? C plus R plus Z is equal to 27. So C should be equal to 9. Then what do we have? We have used this. Then R plus Z anywhere. P plus Q, A plus P. So A plus B is equal to 17. A plus P plus X. A plus P plus X is equal to 23. So the value of X should be 6. So X plus Y is equal to 8. Value of Y should be 2. Then what do we have? What can we find? B plus Q plus Y. Okay. Now Q plus R plus Y is equal to 14. So Q plus 9 plus, sorry, q plus 7 plus 2, q plus 9 is equal to 14, q is equal to 5. Perfect. So b plus q plus y, b plus q plus y is equal to 10, 5 plus 2 7, so b is equal to 3. Now a plus b plus c, do we have a plus b plus c? Singing, yes, a plus b plus c is equal to 22, so 12, so a should be equal to 10. A plus p is 17, so p should be equal to 7, and this completes the set. So all you need to do is you need to frame equations and you need to solve for equations, right? So I can say that this set can be solved in less than 12 minutes only if you have interpreted this statement correctly. Otherwise you will be ending wasting a lot of time. Clear? Now moving to the next set. So 8 students A, B, C, D, E, F, G, and H who are from different colleges X, Y, Z won medals in 3 different races of 100 meters, 200 meters, and 400 meters, but not necessarily in the same order. Now there are not more than 3 students from any college, so you have total 8 students. So you'll be having 3, 3, and 2. And each student has won one medal, and there are 3 medals at maximum for each race event. Again, 3, 3, and 2. Now number of students from college Y and Z are same. So you have 3 students from college Y, 3 students from college Z, 2 students from college X. Perfect. Now H is from college Y. Perfect. So H is from college Y. Now you have 3 students here, so don't mark all crosses in this column. Now D and G are not from same college. So D and G are not from same college. Perfect. Now C is not from college Z. C is not from college Z. Not he has won medal in 100 meters race event. Perfect. Done. Now D won medal in 200 meters race event. Okay. And he is not from college Y. So D is not from college Y. Perfect. Now no student from college Z has won medal in 200 meters race event. So no student from college Z has won medal in 200 meters race event. So since D has won medal in 200 meters race event, I can say that D is not from college Z. So he should be from college X. So you have 2 students from college X, and D is one of them. Perfect. Now number of students who won medals in 100 meters race event is more than the number of students who won medals in 400 meters race event. So this should be 3 and this should be 2 and this should be 3. Consider that. Now student from each college has one medal in 100 meters race. So in 100 meters race, you have students from college X winning a medal, college Y, and college Z. Okay. He is from college Z. And did win medal in 400 meters race event. All the medals of 400 meters race event are won by students of same college. Perfect. Now, who can be the students who has won and from which college who has won medals in the 400 meters race? Cannot be X. Right. Cannot be X. Why? Because we have only 2 students from college X, and one of them is B, who has already won a medal in 200 meters race. And you have, okay, so, and you have one more student who has won medal in 100 meters race. So that person cannot be X. Now, can that person be Y? Now, since there are three students who has won medals in 200 meters race, and we are given that no student from college Z has won medal in 200 meters race event, so this cannot be Z. So the remaining two students should be from college Y. So we are done with two students of college X, three students of college Y. So the students who has won medals in 400 meters race event belong to college Z. Now this is my understanding from this statement. Now we have considered this, we have considered this. Now all the medals of 400 meters race event were won by students of same college. Perfect. Now A and G won medals in same race event, but they are not from same college. So A and G has won medals in the same event, but they are not from same college. So now I can say that A did not win a medal in a 400 meters race and G did not win a medal in 400 meters race, because the persons who have won medals in 400 meters race should be from same college, isn't it? Now we have considered this. So what did we miss? So let's reread this. Let's reread the statements again. Each student has won only one medal, and there are three medals at maximum for each student. Perfect. Number of students from college Y and Z are same. Considered H is from college Y. Okay. So if H is from college Y, I can say that he did not win medal in 400 meters race event. Now D and G are not from same college. Now since D is from college X, G is not from college X. Okay. C is not from college Z, nor he has won medal in 100 meters race event. Okay. So C is not from college Z. So if C is not from college Z, then I can say that he did not win medal in 400 meters race event. So he has won a medal in 200 meters race event, because the students who have won medals in 400 meters race event are from same college. So now we have only two options left, B and F. They have won medals in the 400 meters race event. So they are from college Z. Now we already have three students from college Z, so I can say that no other student will be from college Z. Perfect. Now, two, we are done. Fine. D won medal in 200 meters race event, and he is not from college Y. Okay. Now G, A, C, and G. Fine. E is from college Z and did not win a medal in 400 meters. So E should win, or E has won medal in 100 meters race, because you need to have one person from college Z who has won that medal. Clear? Done. We have considered this. All the medals of 400 meters we have considered this. E and G won medals in the same race event, but they are not from same college. Now, so A and G have won medals in same race event, but they are not from same college. So if I consider that A and G has won medals in 200 meters race event, then you'll be having four persons winning medals in 200 meters race event, which is not possible. So A and G did not win medals in 200 meters race event. They have won in 100 meters race event. Done. Now we have three ticks here, so the remaining two should be crosses. Now H has won a medal in 200 meters race event. Perfect. So G is from college Y. Done. So A, E, and G should be from different colleges. So since we are given that A and G are not from same college, A cannot be from college Y. So A should be from college X. You have two ticks here. So C is from college Y, and this completes this. So this can be solved in, let's say, 12 to 15 minutes, but you should be very confident in solving the questions from puzzles. Okay, so with a good number of after practicing good number of questions from puzzle, this is definitely a doable set. So 6 questions from this set and Venn diagrams, 4 questions. So total you have 10 doable questions in this paper. Now moving to the other question from puzzles. So study the given information and answer the following questions. So you have 5 buses distant from the same bus terminus, started from different starting points and traveled for different times. They started at different times. Now the only challenge in this question is you are given with only 5 statements. So your analysis is important. Okay, rather than using ticks and cross method. So I'll be making a table, 2 tables. One table to make use of ticks and cross method, and another table which gives us the reaching time of these buses depending on the travel time and the time of journey. For example, the bus, if you have a bus starting at 11 o'clock and if its travel time is 1 hour 40 minutes, then the reaching time would be 12 or 40 minutes. So 11 and 25, 13:05, 11 and 2:40, 13:40, 11 and 3 o'clock, 14 at 14 or 2 p.m. and 11 at 11 and 3 hours 25 minutes, it will be 14:25 minutes. So I have made reaching times of these buses when they start at these 5 respective times, and with the time of journeys are these 5 respective timings: 1 hour 40 minutes, 2 hour 5 minutes, 2 hour 40 minutes, 3 hours, and 3 hours 25. Okay, because you will be having a complete information from this question once you made this table. So you can also solve this question without making this table, but I feel making this table is it will make our question or our solution much more easy. Now coming to the information that was given to us. It is also known that no 2 buses reach the bus terminus at the same time. Okay. Bus 1, whose travel time was 2 hours and 5 minutes. Okay. Done. Did not reach the bus terminus before 1:20 or 13:20. So 2 hours 5 minutes. So the reaching time of the bus could be 13:30, 13:50, 13:55 and 14:20 depending on the starting time of the bus. But it could definitely not be in 13:05. So from here I can say that bus 1 did not start at 11 a.m. Done. Now, among the 5 buses, the last bus to reach was bus 3. Okay. So 1, 2, 3, 4, 5. This was bus 3. Now, bus 4 reached the bus terminus after 14:45. Okay. So 14:45. So you can have any of these. So you can have bus 4 reaching at 14:50 or 14:55, 15:10, 15:15 and 15:40. Perfect. But the travel time was not 3 hours and 25 minutes. So bus 4's travel time is not 3 hours of 3 hours and 25 minutes. So it cannot be these 4. Because bus 4 will be reaching at 14:50 when it starts at 11:25 and if the travel time is 3 hours 25 minutes. Okay, 15:10 when it starts at 11:45 and the travel time is 3 hours 25, and similarly for 15:15 and 15:40. Now since we are given that the travel time was not 3 hours 25 minutes, these 4 values are not possible for the reaching time of bus 4. So the bus 4 might reach its destination at either 14:50, 55 and 14, sorry, 15, 15. Now, given that bus 4's travel time was not 3 hours 24, 3 hours 25 minutes. Now, the travel time of bus 4 could be around 2 hours 40 minutes. Sorry, my bad. Bus 4 is not 3 hours 25 minutes. So it could be either 2 hours 40 minutes or 3 hours. It's definitely 1 hour 40 minutes. And I can also say that the starting time of the bus could be either 11:50 or 12:50. So it's not 11:45 or 11:25 or 11 o'clock. So this is where this table becomes handy. Clear? Now, among the 5 buses, at least 3 buses reached the bus terminus before 5 did. So I can say that the 4th bus to reach the bus terminus is bus 5. So bus 5 reached after bus 4. Okay. So I can also say that bus 5 reached after 14:50 for sure. Now, if bus 4 reached the terminus at 14:50, then bus 5 would have reached at 14:55. And if bus 4 reached the terminus at 14:55, then the bus 5 would have reached at 15:15 or 15:10 or 15:40. Cannot be 15:40 because bus 3 is the last bus to reach the terminus. Okay. Now, bus 5 could have either time, the reaching time of bus 5 could be either 14:55 or after 14:55. Clear? So I can say that you cannot have bus 5 starting at 11 o'clock and the travel time of bus 5 cannot be 1:40 and 25. This is also not possible. Now, since we have bus 3 reaching after bus 5, so you cannot have bus 3 starting at 11 o'clock, and the travel time of bus 3 cannot be either 1 hour 40 minutes as well. So now I can be sure of bus 2 starting from 11 o'clock. So this is bus 2 and reaching its destination at 12:40 p.m. Perfect. So this is what I can info from the data that was given to you till now. Now let's use the data with respect to bus 4. So if I consider bus 4 reaching at 15:50, then bus 5 should reach after bus 4, and we are also given that no 2 buses reach the bus terminus at the same time. So if it's reaching at 15:15, then bus 5 should reach at 15:40, which is also not possible because bus 3 was the last bus to reach the terminus. So this is not possible. Now if I assume that bus 4 reached the terminus at 14:55, considering this, so 12 or 15 minutes. So bus 3 has used 12 or 15 minutes as its starting time, and the time of travel was 2 or 40 minutes. Okay, so bus 5 cannot have this, and bus 3 also cannot have it, because you have bus 4 starting at 12:15. So neither of the buses, bus 3 and bus 5, cannot start at or can start at 12:15. Okay, so if I assume that bus 4 is starting or is reaching the destination at 14:55 by starting at 12:15 and traveling for 2 or 40 minutes, then bus 5, the reaching time of bus 5 can be either 15:10 or 15-15. For example, if I consider this 15-10, so in that case, you will be having bus 5 starting at 11:45 and traveling for 3 hours 25 minutes. Now coming to bus 3, but because bus 3 is the last bus to reach the terminus. So if we have bus 5 reaching at 15:10, so bus 3 should reach the terminus by 15:15. But this is not possible because you can have 15:15 when you have bus 3 starting at 11:50, which is possible, and the journey time should be 3 or 25 minutes, which is not possible because we have considered that bus 5 is starting at 11:45 and was reaching the bus terminus at 15:10. So this was already used for bus 5, 3 hours 25 minutes. So you cannot have that. So I can say that you cannot have bus 4 reaching the bus terminus at 14:55. So bus 4 should reach only at 14:50. Now 14:50 is a combination of 3 hours. So bus 4, the time of travel was 3 hours, and bus 4 started at 11:50. Okay. It's not possible. So this should be bus 4 reaching at 14:55 p.m. Now coming to bus 1. Bus 1, you cannot have bus 1 traveling for 3 hours 25 minutes. Okay. Now starting time of bus 1, or just give me 1 minute. And okay, I can't write this. I'm sure that, but I'm sure that bus 4 will be reaching at 14:50. Now, if we have bus 4 reaching at 14:50, bus 5 and bus 3 should reach after 14:50. So you can have bus 5 reaching at 14:55, and then you can have bus 3 reaching at 15:10, because these times should be in 3 different columns and 3 different rows. So 14:55, this is only possible when you have bus 5 starting at 12:15 and the traveling time was 2 hours 40 minutes. Now bus 3's travel time was 3 hours 25 minutes, and the starting time was 11:45. So you have bus 1 starting at 11:25 and the travel time was 2 hours 5 minutes. So 11:25 and 2 hours 5 minutes. So you have bus 1 reaching at 13:30 p.m. Bus 4 reaching at bus 4. Travel time is 3 hours and 11:50. So 14:50 p.m. Sorry, 14:50. This is not right. Now bus 5. Bus 5 starting at 12:15 and traveling for 2 hours 40 minutes. So 14:55 hours, and bus 3 at 15:10 hours. And this completes the set. So when I compare this set with the previous set from puzzles, I consider this was a little bit complicated, and I don't expect anyone to solve this question before the other set, because a lot of analysis and lot of cases are required. So you need to consider as many cases as possible to answer this question. Clear? Now coming to the first set. So 25. So I have arranged the percentage distribution of copper, tin, aluminum, and lead for these 5 alloys in this table. Now let's understand 25th question. If a customer needs an alloy containing at least 25% of lead and at least 25% of tin by mixing exactly two of the five alloys in equal proportions. In how many ways can these two alloys be selected? So you have to mix two alloys from these five. So that can be done in by selecting AB, AC, AD, AE. Then BC, BD, BE, CD, CE, and DE. Now these are the 10 possible ways of selecting two alloys from the given five. Now if I take, and they should be mixed in equal proportion. So one part exactly, and they should be mixed in the ratio 1:1. So let me consider 1 kg of A and 1 kg of B. Now if I take 1 kg of A and 1 kg of B, and we are asked to have at least 25% of lead and 25% of tin. Now if I mix these two, now to have 25%, can I say the sum of these two should be minimum 50? Then only the average will be 25. Now 20 plus 10 is 30. So just by considering these two, I will not be getting an alloy which will contain at least 25% tin and 25% red. So this is not possible. Now if I take AC, 20 plus 40, 60, perfect. And 40 plus 20, 60, perfect. So more than 50. So AC, if you mix alloys A and C in equal proportion, you will get an alloy which has at least 25% lead and 25% tin. Now, if I consider AD, 20 plus 25, 40, 45. No, this is not possible. Now, tin, A and A. So, this is 55 and this is 65. Yes. Now, if I mix BC, so you have 50 here, you have 40 here. So, this is not possible. Now, you have BD, 10 plus 25, 35, not possible. Then B, 10 plus 35, 45, not possible. Then CD, 40 plus 25, 65 possible, 20 plus 20, 40, not possible. Now CE, 40 plus 35, 75, and 20 plus 25, 45, not possible. Then you have D, 25 plus 35, perfect, for 20 plus 25, perfect. So this is not possible, this is not possible. But just give me 1 minute. Now, did I enter values incorrectly? So just let me check once. So this should be 30, I guess. So if that was 30, then AD is not possible. BD is not possible. CD 40 plus 25, 65, 30 plus 20, 50. So CD. So CD is possible. Then again, DE is also possible. So you have 4 ways of selecting two alloys from these five so that the resultant alloy will have at least 25% lead and 25% tin. Now this is an easy question from the given set and the answer is given as 5, which is incorrect. The answer for this question should be 4. Now there is some issue in this question, guys, because after seeing solution, I sense something is incorrect with respect to this question. So you can leave 26. Now 27. If an ideal alloy is one which contains all the 4 metals in equal proportions and exactly 3 of the given 5 alloys have to be mixed in the ratio 1:1:2 to get the ideal alloy, then which of the following combinations of alloys can be used? Not necessarily mixing the alloys in the order of the preferences. Okay, so A, B, C. So the ratios can be either 1:1:2, 1:1:2, 1:2:1, and 2:1:1. For example, if I mix one part of A and one part of B, 70 plus 40, 110. Then 20 plus 10 plus 80, 110 plus aluminum, 10 plus 30, 40, 40 plus 40, 80. So this cannot be. Now 1 is to 2 is to 1. Now 30, 30 plus, because all these four should be in equal proportion, right? So 30 plus 80 plus 20, 130. Now 20 plus 20 plus 40, which will be equal to 80. So this cannot be. Now 2 is to 1 is to 1. So 60 plus 40 plus 20, 120. Now 40 plus 10, 50, 50 plus 40, 90. So this cannot be. So option A cannot be the answer. So for every option, you will be having three cases where you can have alloy A, B, and C, or these three alloys being mixed in 1 is to root 2, or 1 is to 2 is to 1, or 2 is to 1 is to 1. So just by verifying the options, you can answer this question, but it will take slightly more time, 3 to 4 minutes. But you will be getting up having an confirmed answer, correct answer for this question. Now 28. What is the least cost in per kg of a mixture of more than one alloy, given that it contains at least 25% copper and at least 25% tin? And we are given that the prices of 1 kg of alloy A is 200, this is 240, then this is 230, then this is 220 and 215 respectively. And you need to find a mixture of more than one alloy, given that it contains at least 25% copper and 25% tin. Okay, so you should be considering at least two out of these five alloys. So I will be taking alloy A and alloy E because they have the minimum prices per kg. So let me take A and E. Now the ratio of or the copper percentage should be minimum 25% in the resultant alloy, and tin should be 25%. Okay, now this is 30 and copper in E is 25. So to have 25%, obviously, okay, the mixture between these two will have at least 25% of copper for sure. Now coming to tin. Now E has 20% of tin and E has 35% of tin. Okay, so in order to have 25% in the resultant mixture, they should be mixed in the ratio. This is 10 and this is 5. 10 is to 5, nothing but 2 is to 1. So let us consider 2 kgs of alloy A and 1 kg of alloy E. So 2 into 200 plus 1 into 215. And this is the price of total 3 kgs of the mixture. So divided by 3. And this will give you the least cost per kg of the mixture of more than one alloy, given that it contains at least 25% copper and 25%. And this completes the LRDI section of mock plan. So I rate this on a moderate to difficult side, definitely not an easy paper to attempt. Okay, so but you guys should be ready when you get this type of section of this difficulty in your main cut. So ideally you need to score minimum of 18 marks in this paper if you pick the puzzle set which has 6 questions. And if you're good at Venn diagrams, that is an easy question. So you can get at least students with good preparation should be able to score 10 questions under 30 marks in this paper first. Clear? So practice. If you do not get any questions or if you do not understand solutions of any of these 4 sets, you can reach out to me and we can discuss the solution in detail. Okay, so start practicing, guys. Analyze, please solve the questions that you did not get in the mock once again. So please be confident about answering the questions that were asked in the previous mocks if they are repeated in the other mocks as well. Now, these are some important things that you need to do in addition to the analysis of any mock. Okay, so that's it for logical reasoning section, guys, and all the best for the next mock. Thank you.